In this video we're going to have a look at the 2017 question from the higher level paper 2017 question C1. Just to go through the question here, first of all, you're told here the accompanying map located on the back of section A shows ground contours at 5 metre vertical intervals. Okay, so that's the first thing kind of to take note of there, 5 metre vertical intervals on a proposed ski run. The map on the map ABCD is the centre line of the ski run. Okay, so we have the centre line of the ski run ABCD. The proportion of the ski run between A and B is level at an altitude of 65 metres. Okay, so again we should be writing in, so A is at 65 metres and B obviously will be at, if it's level, it has to be at 65 metres as well. Okay. The portion of the ski run from B to C is falling uniformly to a level of 50 metres at C. So C is going to be at 50 metres. And the portion of the ski run from C to D is level at an altitude of 50 metres and is widened on its northern side as shown. So D is also at 50 metres. So between B and D is level, or between C and D is level there at 50 metres. So the only place it is actually fallen, it's fallen away from 65 metres down to 50 here, so it's fallen by 15 metres there of a fall. So that's the only place it's fallen. So again, it's a good idea just to take it from the start, write in your altitudes there first of all. Okay. Now, you're told they're using side slopes of 1 and 1.5 for the cuttings, so 1 and 1.5, and 1 and 2 for the embankments. Complete the earthworks necessary for the ski run between A and D on the northern side. Okay, so between A and D. You may ignore the southern side, you're told, so we don't have to worry about it anywhere down below here. So the first thing we want to just write out here, it'll be handy for you in the page, just in the corner of the page, somewhere that's going to be out of the way, is we're going to write in our cut and our fill slope. So we can see here our cut ratio is 1 and 1.5. So that means we're at 5 metre vertical intervals here. So for every 5 metre of a rise in the cut, it will be will have to come out 7.5 metres. And likewise for the fill, it's 1 in 2. So for every 5 metre drop in the ground, we'll have to come out 10. Okay. Our scale is 1 to 1,000. So that basically means for every 1 millimetre on the map represents 1,000 millimetres in reality. So that, if we write that out, that's 1 millimetre will equal to, it's the same as 1 metre. And these are 5 metre vertical intervals here. So if we have a 5 metre change here, that will basically mean we have to have, for every 5 millimetres on the map will represent 5 metres in reality. So 5 millimetres on the map will represent 5 metres in reality. So we're told that the portion between A and B is level at an altitude of 65 metres. You can see the ground to the northern, so we're only worried about the northern side here. We can see the ground to the northern side here of the actual ski run here is at 70, 75, 80, 85, 90. So it's all higher. This ground here is all higher than the actual ski slope between A and B. A and B is only at 65. So we know that all this is going to be a cut. So this is going to be a cut here. We're going to have to cut into this ground here to cut away the ground to have enough room for this here. Okay. So our cut, if we come back to our cut ratio here, we're at 5 metre vertical intervals. So for every 5 metre change in altitude, we're going to have to come out 7.5 metres. So if we're using that in relation to our drawn here, so we're going to have to come out for every change here, we're going to have to come out 7.5 millimetres here each time. Okay, so we're just going to use our set square here. We're going to start at the edge of the ski run here, and each time here we're going to come out here are 7.5 millimetres. Now you can do this also with your compass, maybe just a little bit quicker and handier here if we just take 7.5 besides trying to measure it out each time here. Okay, we're just going to take 7.5 millimetres here, and I'm just going to use this line here at the edge here as my guide here, and I'm going to go 7.5 each time I come out there, and each time I come out there that means I'm changing it in altitude of 5 metres. So because of the cutting, each time we come out it's going to be a change in altitude of 5 metres there. Okay, so this line here is at 65 metres here, so we're going up the way now, so we're going to 70 here, 75, 80, 85, and we have to go as far as, our highest one here would be 90, so we'll go as far as 90 there. Okay, so for each one of them. So nice and straightforward now. Okay, so we just draw them in. Our lines, because it's a level run, the ski run is level, we can draw our lines parallel with the edge of the road. We do not need a cut or a fill cone here this time. Okay, so each one of them lines represents a difference in altitude. We just pick them out then. Okay, so this is our 70 line here and our 70 line here, so that's 1 point there. This is at 65 already, so we're moving on then to 75, 80, just take your time, it's easy to make a mistake here, 85, then we're going to 90, twice on 90 there, and back to, we probably don't need to go much further than that now, okay, because we're getting into the next part of the road here. We'll just go as far as 90 there. I don't think we'll have to, and if we do afterwards we can, but I don't think we'll have to go much further than there. Okay, so for now we'll draw this in just lightly. Okay, so we'll just ghost this one in for now. We don't know, we don't have a contour here that's going to actually come back to the road here, so what we're going to do is we're just going to assume that that'll continue on past there. It won't actually go to the corner here, it'll just continue past on that point there. So we just ghost that in for now, nice and lightly, and afterwards when we have this section of the road done, we can come back then and we can draw it in a little bit heavier then, because this side is going to join here to this part here. It's going to overlap here somewhere, so we're going to need to get the overlap wherever it overlaps. We may have to come on another one with this one, I'm not just sure yet till we get on that far. We're happy with that, we've that much set up. So that's kind of the first part of the road done there. Now you're told then, in the second part, the portion of the ski run from B to C is falling uniformly to a level of 50 metres at sea. And we already have that set up there, we have a level of 50 metres at sea there. So if our road drops here from 65 down to 50, our road has dropped by 15 metres, okay? Our road has dropped by 15 metres here, okay? So if our road drops by 15 metres here, we're going to have to come out in whatever ratio we're told to that. So again, if we look here, we're at 65 metres here, and we go down to 50 here. Again, this will all be a cutting because we're at 90 here, 85, 80, 75, 70, 65. All this ground here, if you look at the contours, is going to be higher than the ski run itself. So we're going to have a cutting here. So the first thing you need to consider, okay, it's a sloping road. We're going to have a cutting. The road is sloping downwards here. A cut cone always is an inverted cone, and it goes at the lowest part of the road. A fill cone goes at the highest part. So the lowest part of the road, we're going to have our cut cone here. Okay, so our cut cone is going to be here somewhere. Now all we need to do is determine the radius. Well, we've dropped 15 metres here, so if we come back here to this, if we had dropped 15 metres on this, we need to come out here by 22.5 metres. Because we're at a ratio of 1 in 1.5 here, so if we have a ratio of 1 in 1.5 here, if we were to continue that on and we were to say 1 in 1.5, so if we were to take 15 metres and multiply that by 1.5, we would end up with 22.5 there. Okay, so it'll be 15 is to 22.5 is the equivalent of 1 is to 1.5. So if we were to take our 15 metres, so we have a 15 metre drop here, if we multiply that by 1.5, we get 22.5 metres out here. So our radius of our cut cone is going to be 22.5, okay? And the centre of the cut cone is always at the edge of the road, okay? So it's 22.5, and we can draw in our cut cone there. Okay, so that is our cut cone. It's an inverted cone. It's an inverted cone, and it's on the lowest part of, I just write in cut. It's on the lowest part of the road there, so it's an inverted cone. So because it's an inverted cone, as we move away from the apex of the cone, we're rising in altitude. Okay, as we move away from the apex of the cone, we're rising in altitude. If it was a fill cone, it will be a cone the correct way up, and as we move away from the apex, we will be dropping down. But because it's a cut cone, we're moving up along the side of that cut cone as it goes up. So as we move up, we're increasing in altitude. So the first thing we need to do there is join a tangent from the edge of the road at point B to the outside of the cut cone. Now you don't need to do the construction for the tangent here, you just need to draw it in. Okay, so that line there is at the altitude of whatever point this is here. So that's 65 meters. That's that line is at 65 meters there. Okay. Now, what I'm just going to do here is I'm going to set up a line that's just like we did before. I'm just going to set up a line that's at 90 degrees to that, just so I am accurate with my points going out from that then. Okay, so I'm just going to set up a line going out here, and I'm going to, again, we're going to be looking at, because it's a cut, and that may actually need to extend down this way a little bit as well. So that line, I'm just going to extend it down the way a little bit as well. So for each time I move out here, I'm going to move out, because I'm going to move out the same distance here because it's a cut, I'm going to move out at a ratio of 1 and 1.5, so I'm going to move out 7.5 each time there. Okay, so I hope that makes sense in relation to the ratios. It's just figuring out your ratios for it. Okay, so each time I move out here, I'm for each one of these I'm going out 7.5 millimeters here. So because I have a ratio of 1 and 1.5 and the vertical intervals are 5 meters, if you multiply 5 meters by 1.5 you get 7.5, and that's why we're doing this here. Okay, so at each one of them then, if I mark them in now, okay, so this point here is at 65, and if we move out, as we go out the way, we're going increasing in altitude. So we're going to 70, 75, 80, 85, and we probably don't even have to, we do, we have to go to 90 there, okay, and we go to 90 here, okay, and as we go down this way, the closer we get to the apex, so the apex of the cone is right there. It's an inverted cone, so that means it's an upside down. You're looking at the base of it is closest to your view here. So this here will be 60 and 55, okay, and I don't think we'll have to go any lower than 55. We're at 50 there. That should see us out there. Okay, so again, you can use either your sliding set squares here or your adjustable set square, whichever you're most comfortable with now. Okay, I'm just going to use sometimes in these questions here, it can be just as quick and handy just to use your it can just be as quick and handy just to use your sliding set squares, but it's entirely up to yourself. Okay, it's whatever you feel most comfortable. You just need to make sure that your lines are parallel. Don't be afraid to draw your lines nice and long. You're not you're not going to, as long as you have the lines in and they're not really heavy or anything like that, they're not going to confuse you afterwards. It's nice just to have them there full length along, and then we can pick them out as we go along then. Okay, so we're at 85 there. Again, just take your time, and we're at 90 there. Okay, so we've them marked out there like that, and we have them drawn in now. So all we need to do now is start. I would always start at the opposite end of the cone and work my way towards the cone. Okay, so we're at 65 here. Okay, so as we work up or as we work down, we will find our different lines here. So this is our 90 line here. Okay, and obviously you're going to see here we have a point here at 90 millimeters at our 90 line here. So where our 90 intersects with this, and what we can see is we haven't actually intersected this other one, so we may actually have to come over. That will be our 90 line there as it goes along the whole way over to here. Okay, and we will obviously have our 85 line is there as well. Okay, so we just extend them on a little bit there, and what you'll actually find is your 85 line will intersect there, and we'll have our 90 line there. So this one will actually come down here and go across to there. So we just work on from that there then. Okay, so we're at our 85 line here. Okay, so that's 85 there to there, 80, 75, back down to 70, 65, okay, and we're at 60 there, and we're down to 55 there as we go, and this point here will be 50 there at the road there where it intersects with this line here. So that's our 50 line there. So we're coming up here and we're going round till we meet there like that. So we just ghost that in there. Now you'll be starting here. Okay, this is where if we were to continue this on here, you'd have another point down here. So this is our 80 line If we were to continue this on here, we'd have an 80 point down here, but we have the point here where our 85 one crosses our 85 here, which also crosses our 85 one here, okay? So they all kind of cross there together, and that gives us that point there. So this is going from here back around to here, and we're moving on in this direction here. So again, just nice and carefully, I'm just ghosting this in. I'm not putting this heavy for now. That's that much there. We have the point at where it crosses, so I can now draw in the full. So I can leave that out. Even though it's drawn in lightly, I'll leave it there to show my construction, and I can start here now. Nice and carefully. Work my way around to there, okay? And that's the line that has been left there that's ghosted in. I can leave that there like that, that's fine. Now I will, from there to where the road begins to change, so I'm going to join that point. So where my slope and fill, or where my slope and cut, I should say, has intersects with my parallel cut here, I will just join from that point with a straight line back like that there, okay? So that's where that line intersects with this line here, okay? So that's that much done there. That's the sloping part of the road done there, and that's that much there, okay? So we just have a look now at the next part. So you're told then the portion of the ski run from C to D is level at an altitude of 50 metres and is widened on the northern side as shown, okay? So it's level at an altitude of 50. So it's 50 at sea, this is all 50 metres here. Now if you look at your contours, I know of these written in here now, but if you look at your contours, that's at 50, then we're going back down to 45, 40, 35, 30, 30, 30. All this here is clear to see from this point on is lower than the ski slope, than the level ski slope here. So that means we're going to have to fill all this area up with fill to create an embankment up to the road like that there. So we're going to have to embank everything up to the road. So if we look at our fill ratio here, we have a fill of ratio of 1 and 2. So for every 5 metre difference in altitude, we're going to have to multiply that by 2, which will give us 10 metres. So 10 metres in reality, and when we scale that down, it's 10 millimetres on our page here. Okay, so we're going to start here at this one here. We'll have to go parallel to that edge there again. So what I'm going to do here first of all is I'm just going to set up, again, just to be accurate and to show that you're being accurate about these things. I'm going to set up a line here coming out from this point here at 90 degrees to that edge. So what I'm going to do is on that line then we're going to measure out our intervals there of in 10 millimetres. Now I hope that's clear where that 10 millimetres is coming from. It's because we have a fill ratio of 1 and 2. So we have 1 and 2, we'll probably have 3 different, because it will be doing about 3 of them here, we'll have 3 different, so that will be going out the way. Now because this is a fill here, each time we move out away from the road, we are dropping. So this time we're increasing, this time now we're dropping in altitudes as we move out from the road there. So if we were to mark then altitudes, if we were to actually mark them in there now, so this edge is at 50 metres, so as we move out here now, so this will be at 40, 45, 40, 35 and 30 as we move out there, okay? So what we can do now, again, just with your sliding set squares, you can set this up and you can, nice and carefully. Now this is where things can overlap a little bit, and you just need to be careful of the lines, the contour lines from the previous part of the question. Just double check that you're not getting things mixed up, okay? It can be easy to get things mixed up. Now I should be extending maybe them on a little bit there as well, the other side of that line, for them too there. Okay, so just make sure that things aren't getting a little bit messed up there, okay? So we have our 45 line here, okay? We already have our 50, so we'll be starting here at 50, and then we'll be going out to our 45 contour line here, where it meets our 45 line there. That gives us our point there. Again, same for our 40. Our 40 contour line will meet our 40 there. Our 35 contour line will meet our 35 there. And we probably will not need to go one more, then our 30 contour line will meet our 30 there. Again, we don't know where this one is going to meet this one here at the corner here somewhere, so we just ghost this in for now, in lightly, and then afterwards we'll come back and we'll draw it in heavily once we've crossed the point. So it's relatively straight here. I don't think I need to go any further than that. So now what I need to do is I'm going to use this edge here, coming out here from this one here. I'm going to do the very same thing. So again, I'm going to use my 10 meter intervals, so it'll be 10 millimeters because it's a ratio of 1 and 2 over 5 meter vertical intervals. So each one of them will be a difference in 5 meters there. So we're at 50 meters here at the edge. So this will be 45, again like before, 40, 35 and 30. And I won't have to go any further than 30 because 30 is my lowest contour here. Okay, so once I have that much there, what I can do is I can draw out my contour lines just with my T-square. Okay, so at each one of them points now, I can start drawing this out. So I can see my 45 contour is there, 40 there, 35 is there, so my 35 line, 30, and 30 line and my 30 line, and again I have another 30 and another 30 here. Okay, and I'm gone back to 35 then, so I'll have to come back down here to my 35 line there, and we'll have to go another one now to our 40, and I have my 40 here. So I went to 35 from here to there, that gave me that point, but I still won't overlap this line with that point, so I'll have to go another point past the line. So I go to the 40 with the 40 there, and that gives me a point there. Okay, that gives me a point there, and where that crosses that one, then that will give me the contour. Okay, so I'll just ghost in now this one here. So I'll start here at the 35. I'll just work from left to right a little bit easier, and you can see I've crossed my previous contour, curve between the points, and I can bring this over and down to there, and it will just continue on like that. Okay, so now I have the point there at where they cross each other, so this contour line. So once I have that much, I can leave that there because it just shows my construction if it's in likely, and I can come along now and I can just, with one smooth action, I can draw it in like that. Okay, and I can draw in from that point now back to the corner. Where it turns the corner there, we'll have an edge like that there. Okay, and that is that part of the question done. Now, so I need to put in the balloons now. Okay, so this here is an embankment here. So the lowest part, so this edge going around here is all lower than the actual ski run here. So if you were standing down here and you let go of the balloon, it would head up towards the road. Same here. Okay, we'll head up towards the road. Now, this is our cutting over here. So all this is a cutting. So the lowest part, all this edge, the whole edge up here, is all higher than the ski slope itself. So that's the higher point. So that bankment is heading up away from that ski slope. So if you were standing on the ski slope and let go of the balloon, it would head up towards that cutting there. Okay, so that's that much of the question done there. Okay, so that's part A of the question done there. Okay, so what we're looking at then for part B is, in the space provided at the top of the map, draw the vertical section or the profile through the ski run and the line EF. Okay, vertical towers are constructed. Okay, we'll worry about this part first. Okay, so we just have to draw in the profile at EF there. Okay, now there's a lot of this has already been set up for you there. Okay, so you have from E to F, so I'll just bring up E there, and F is already actually brought up for you there. We're already given this contour line here at 50 meters in height. Okay, so what we can do there is, from there I would actually, so we brought up that line there from E. What we're going to do here is I'm actually going to draw in the rest of them contour lines. So we're at 5 meter vertical intervals. That means for every 5 millimeters we move up here, that represents 5 meters in reality. So I'm going to go up here 5 millimeters each time. Okay, and likewise I'm going to go down the way here. Okay, so I'm going to draw in them contour lines going across there now. Okay, so that's our contours drawn in there. If we actually label these like it's been labelled here, so as we move down the way, obviously we'll go up the way here, so we're going up to 55, 60. And you can use that one there as 95 up there, okay? And as we go back down the way, obviously we're going 45, 40 down. Okay, so we've that set up there now, okay? And what you're told in your question is, in space provided, draw the vertical section profile through the ski run at the line EF, okay? So you know E here is at 65 meters, because this from A to B is level at 65 meters, so E has to be at 65 meters up here. So we're going to mark in, just going to mark in E there is at 65 meters, okay? So between E, B is at the same, so B is at 65 meters also. So again, that's going to be B there. And then going from B down to C, C is at 50 meters, which is already marked for you in the red there, so I'm going to go write that in as B. And F is there, and it's level there as well, okay? So we're going to, or sorry, that should be C there, okay, sorry. C is at 50 meters there, okay? So we're going to join B to C to F, so that's the slope of the ski run, heading back down there like that, and it's going across to F there, and it's going across to E there like that, okay? So that is the level of the ski run there, okay? So what you're asked to do in the space provided at the top of the map, draw the vertical section through the ski run at the line EF, okay? So we've done that, okay? Now, so that's the ski run there, okay? So vertical towers are constructed at points E and F to support a steel cable for ski lifts, so kind of like what you see on the picture here, okay? The cable is 15 meters and 20 meters above the ground at point E and F respectively. Determine the maximum vertical distance between the cable and the ground. Assume that the cable is a straight line. So what they're saying there is assume that it's not kind of sagging down or dipping down like a clothesline or something like that. Okay. So at E and F, so that means at E it's at 15 meters and at F it's at 20 meters. So if we come back to our drawing here, at E here we're told that the ski pole is, so we'll just draw in this here, is 15, it's 15 meters above E. So 5, 10, 15 meters, so it'll be up to 80 meters there. Okay, so that's where it is there. And you're told at F it's at 20 meters above. So at F then it's going to be going up to 5, 10, 15, 20 meters above F, which is 70 meters there. And that is the point of the top of the cable there, or the pole there, and that's the cable there. Now, what we can do there, if we join them together, so that is basically the cable going along there. That is the cable going along there. Okay, so this is the ground, and that's the cable being joined along there. Now, what you're asked there for is determine the maximum vertical distance between the cable and the ground, and assume the cable is a straight line. So we've assumed the cable is a straight line, we've drawn it. Now, where is the maximum vertical distance there between the cable and the ground? Okay, it's not here because the cable is sloping up here. C and F are at the same altitude, so C and F are level. It's not. The distance between C and the cable is a little bit more than C and F because the cable is sloping up away. Okay, so the maximum vertical distance there between the cable and the ground there, I'm just going to draw this in a colour here now, is between C and the cable right there. So there and there. Okay, now if we measure this, I'm just going to use my compass here to actually measure this, and we measure that as being 22 meters on my drawing there. Okay, so we're going to write in there 22 meters there. Okay, and that's the maximum vertical distance there. So that's part B of the question done there. Okay, that's part B of the question done there. Okay, so what we're looking at for part C is on the map. P and Q are 2 points on the surface of the Earth. Okay, so P and Q, let's get them here. P and Q are 2 points on the surface of the Earth. So on the surface, vertical boreholes at these points reveal the top surface of the stratum of ore at altitudes, very important, altitudes of 50 meters and 35 meters respectively. A skew borehole at Q is drilled in an easterly direction, has an inclination of 55 degrees to the horizontal plane. It reveals the top surface of the stratum at an altitude of 30 meters. In the space provided at the top of the map, draw the elevation of this triangular portion of the top surface of the stratum. Draw the plan of the triangle and determine the strike and dip of the stratum. Okay, this is a lot more straightforward than it first appears. Okay, we're going to take the first part first. Okay, on the map, P and Q are 2 points on the surface of the Earth. So these are 2 points on the surface. They're drilled down. There's a vertical borehole drilled straight down there at P and straight down there at Q. Okay, and it reveals the top surface of the stratum of ore at altitudes. Very important, not distances now, altitudes of 50 and 35 meters respectively. So that means it reveals P at an altitude of 50 meters. So at an altitude of 50 meters, which is right on our red line here. So that there is our point P. And it reveals Q at an altitude of 35 meters. So if we bring up Q here, it reveals Q at an altitude of 35 meters. Okay, so that is our point Q there. Okay, now what's that saying is basically if we were to start at the surface of the ground there and drill down from there, we would reveal P at that altitude there, and we would have drilled down from Q is actually way up here at the top, but it reveals the surface of the stratum here, down here at Q down here. Okay, so there'd be a drill bit that drilled down through the full way down through the ground here, and it revealed the stratum at an altitude of 35 meters here. So our actual, where the hole started was way up here on the surface of the ground. Likewise, well, if you look here, Q is actually at 90. So the drill bit would have actually started up here. If we extend this one up here, Q, so I'll put Q in red up here now because that's actually Q there. That is where Q would have started. It was a drill bit, that's the surface of the earth up here, okay? That's the surface of the ground, so that's where the grass is up here. Somebody would came along with a drill bit, a big drill, and they would start drilling down there through Q until they met the surface of the stratum here at 35 metres here, okay? The same would have been done at P, wherever, we don't just have an actual height for P here, wherever the surface of the ground would have been up around here somewhere, drilled down through P until they found the surface of the stratum at P, at 50 metres, okay? So that's the first part there, okay? Now you're told a skew borehole at Q is drilled in an easterly direction and has an inclination of 55 metres to the horizontal plane. It reveals the top surface of the stratum at an altitude of 30 metres. Right, okay, so if you're drilling in plan, if you're drilling in an easterly direction, in plan, you're going to the east. So you have the little icon here, you have the little north, south, east, west. So you're going exactly to the right here in plan, okay? So you're going to the right there in plan, somewhere along that line there. So that's eastwardly in plan. Now, that line there will be heading down in this direction here, somewhere in elevation. You started at Q, so you started at the surface. We're not starting down here because that's the stratum of O, that's below the level of the ground. This is the level of the ground here. Q is at 90 metres here, so it's at 90 metres up here. That's the level of the ground there. So you would be starting your drill bit, instead of going vertically this time, which we did to find Q, to find the top of the stratum here, we went and we drilled in an easterly direction at an angle of 55 degrees here, down through the ground, until we found the top surface of the stratum of the ore at an altitude of 30 metres. So what you're going to have to do there is we're going to set up an angle here at an inclination of 55 degrees to the horizontal plane, okay? So you're going to set up an angle here of 55 degrees to the horizontal plane. So the point Q, drill down through that line there at an inclination of 55 degrees to the horizontal plane. So if we're doing this, so this line needs to be at 55 degrees here. So if it's at 55 degrees here, this angle here would also be at 55 degrees up here. So if we measure this using our alternate angles, we'll be at 55 degrees here. So set this up carefully here. We measure to 55 degrees there and draw in our skew borehole. Okay, so I'm going to draw this in yellow because I've drawn in yellow down below. Okay, that's our skew borehole. It has been drilled at an angle of, so your inclination to the horizontal plane should be 55 degrees there, like that. Okay, so it reveals the surface of the stratum at an altitude of 30 metres. Okay, so right there, it reveals the surface of the stratum right there. Okay, so what we're going to do here is we're actually just going to we'll call that R for now. Okay, we'll call that point R. Okay, so we drilled down, started at the surface there, drilled down at 55 degrees, and we found R at that point there. So now at this point now, I can now draw in the surface. I can join the 3 points together to create a triangular plane that's on the surface of that stratum of ore. Okay. Now I can also bring down R, and I can find it in. I can bring down R, and I can find it in my plan there, because I went in an easterly direction, like this. So I'm going totally to the east. So it's somewhere along this line. So where it intersects with that line going there, that gives me my point there, and I'm going to call that again R down here. So now I can join up P, Q and R. like so. Okay, so that's that part of the question done. In the space provided at the top of the map, draw the elevation of this triangular portion of the top surface of the stratum. Draw the plan of the triangle, we've done that, and determine the strike and dip of the stratum. So we're nearly there. So strike and dip. So strike is a level line on the surface of the stratum of ore, or the surface of the plane. So if I set up, the easiest place to set up my strike line here would be go level across from Q until I meet the line there. Okay, and I'm going to call that point O there, and I'm going to bring that straight down. So that intersects the line PR down here. So that's point O. And if I draw this in here now, that is now my strike line. Okay, so that's the strike done. One last part to do now in order to finish the question, to find the dip. So if I look along that strike line, so parallel with that strike line, and bring out all my points here. Okay, and what I can do here is I can set up my new XY line. So once it's out away from it, it's fine. So that's my X1, Y1 line. Now I already have the heights of P, Q and R, so I know I can even take them, but I can take my heights of P, Q and R there. So P is at 50. Q is at 35. And R then is at 30. Okay, they should join to form a straight line then. Come on. Okay, so that is my points there, P, Q and R. And all I have to do then is I can just set that up to show parallel line . And that is my dip. Okay, and that is the question answered then. Right, okay, so that is the full solution to the question there now. Okay, you just set it up, take it step by step. If you were to try and look too far ahead in the question and do too much at once, you'd obviously go wrong there. Okay, so a little bit of colour might be no harm if you want to use some likes of fine line pens, but the only thing about using them is if you make a mistake, there's no going back. So stick to your pencils is the best idea. You may want to use maybe a colour for the likes of these here, or afterwards when you're finished, to write in the main elements of it and you know everything is right. But the likes of drawing in lines in colour, if you go wrong, they're there and you can't rub them out. Okay, so I hope that's helpful. That's for 2017 C1.